Hi, this is just a quick demonstration to show how to wind a baseball bat using CAD wind. We've started from a CAD drawing. In this case I've used Pro Engineer and I've drawn the profile shape of the baseball bat. I've used dashed lines to control where the frames will fall on the CAD wind mandrel. From here we just save it as a DXF file, AutoCAD standard DXF. We can close the CAD window and go back to CAD wind. From CAD wind we choose DXF to contour. That will convert the DXF file we just made into a CAD wind mandrel. We just need to choose a name for the new mandrel. And we can load the mandrel now. Here we can see the mandrel that we've just created. We can zoom in, spin it around, make sure that it's all looking correct the way we expect it to be. Looks pretty good. So now that the mandrel's ready, we can define the winding parameters. First step is to define the material. In this case, we're going to use one roving with 0.2 inch bandwidth. Define the winding angle and the non-geodesic winding parameters. In this case, we're going to wind with a 45-degree fiber angle and the friction factor, which I worked out before to optimize this winding, 0.116. We can also choose the pattern number. From my previous experiments, I found that a 7/5 pattern works quite well. Took me about an hour, I suppose, of experimentation to find the best set of winding parameters for this particular shape. It's a little more complicated than usual. Normally this process is only a few minutes. Once we're happy with the winding parameters entered in this window, we can click Start Winding. And after a few seconds, CAD wind finishes the calculations of the winding path and displays the result on the screen. Again, we can zoom in, zoom out, have a look from different angles. Make sure that the winding looks nice before we continue. Looks pretty good to me. So when we're ready, we can move on to the next step, which is defining the part program and starting the simulation of the machine movements. We find that under the post-processing menu, post-processing parameters. And here we enter the parameters for the post-processing, which will determine the way that the machine moves and how fast the machine moves during the winding. I'm going to choose a minimal distance of 3/4 of an inch. That's the distance from the head of the machine to the mandrel. And when we're happy with that these parameters are all entered correctly, we can give a name to the part program. And click Control Data to make the part program and start the simulation. Just takes about a second to do that. And you can see straight away we've started a simulation of the movement of the machine and the winding of the bat. Just spin that around, give you a three-dimensional view of what's happening. Sorry. So he's doing a pretty good job slowing down at the ends. Notice the head of the machine automatically rises up at the handle here to avoid hitting it. We can stop the simulation, have a closer look what's happening there. Play it in slow motion, one frame at a time. You see it really, it's maintaining that minimal distance that we entered before, 3/4 of an inch. Even around tricky geometry like that. So there's really very little chance of collision with the machine. You can control the speed of the video or the simulation with this box. We're at 105% of machine speed there. Speed it up by entering 200%. Obviously the machine's simulation is moving much faster now than the machine would actually move in real life. Slow it down, of course. We're interested in what's happening at the end here. Slow it right down and get a zoom in to really see what's happening at that little bit of detail at the end. See the head of the machine dipping down to wind over the end of the bat. And then turning around and continuing on the return path. The axes of the machine are displayed. This red line represents the cross carriage axis or the radial axis of the machine. The green line represents the possible travel in the carriage axis. So you can see if any of the axes go past their limits, it's immediately obvious in CADwind, and it will give you a warning message as well if that happens. Let's see if we can speed this up and show you the end result. Possible to display the floor of the workshop underneath the machine also. So you can see how far above the floor your winding is. Also you can display numerical data, position of the machine at any point. And it looks like the winding of this helical layer is finished.